In this video, we're going to take a look at 3 different types of transformations. We're going to start with translations. So a translation is simply when you slide your figure, your shape, your point, whatever it is that you're dealing with. So let's say we have a triangle with 3 random points. We'll put a point at 3, 4, a point at 6, 6, and a point at 6, 2. When we're doing a translation, we're going to be given a rule. It might be something like you're going to move your shape 2 places to the left and 3 places up. When you're given this, you can do 2 things. The first thing you could do is you can go to your graph and you can simply move each point 3 places up and 2 places to the left. What you can also do is create a rule. Remember that you have your X and Y axis. If you're moving 2 to the left, that's on your X axis, and when you move to the left, that's negative. So you can write a rule where you're subtracting 2 because it's negative. And then if you're going 3 up, that's your Y axis, and it's going 3 positive. So you add 3. So I can take those 3 coordinates that I have, the 3, 4, the 6, 6, and the 6, 2, and I can use that rule to find my new points. So I'll start with the x minus 2. That means I take my x coordinate and I subtract 2. So 3 minus 2 is 1. 6 minus 2 is 4. And then I do the same thing with my y. So I take my y value and I add 3. So 4 plus 3 is 7. 6 plus 3 is 9. And 2 plus 3 is 5. I like to do it using that rule way, but you can also just go to your graph. So you look at what it tells you to do, 2 to the left, and you move each point 2 to the left, and then it says 3 up. So I move every point 3 spaces up, and I get my new coordinate. I do that for each one. 2 to the left, and 3 up, and then once again 2 to the left, and 3 up. And what you'll see, if you take those coordinates and you write them out, you get 4, 9, which is what we already got right here. You get 1, 7, which we already got right here. And you get 4, 5, which once again, we already got. So that's a translation. You have a congruent shape, so it's the exact same shape, and it has the exact same orientation. Next, we're going to take a look at a reflection. So a reflection is simply when you flip a shape. And all of your reflections are going to take place over one of the axes. So once again, we'll stick with our triangles. This time our coordinates are 4, 6, 6, 3, and 2, 4. And we're going to be told to reflect it over one of the axes. So let's say we're reflecting over the x-axis. There, once again, are 2 ways you can do it. The first way you can do it is you can take each of those points and you can count how many places away it is from the x-axis. So this point is 4 away from the x-axis. So 1, 2, 3, 4. And you do that in the opposite direction. 1, 2, 3, 4. And you put a new point. And you do that for each of the points. This one is 6 places away. So we go 6 in the opposite direction and place our new point. And the last point is 3 away. So we go 3 in the opposite direction and place our point. And that would be our reflection. Our new coordinates would be 6, -3, 4, comma, negative 6, and 2, comma, negative 4. What you'll notice is that whenever we reflect over the x-axis, our y value is the opposite. So if it was positive, it's now negative. Same thing if we were to reflect over the y-axis. So you can, once again, just count how many spaces it is. So this is 4 spaces away, so we go 4 spaces in the opposite direction. And this is 6 spaces away, so we go 6 spaces in the opposite direction, and we place our points. And what you'll notice is if you take each of those coordinates, 2, 4, 4, 6, and 6, 3, all you're doing in a reflection over the y-axis is getting an opposite x value. So if it was 2, it's now negative 2. If it was 4, it's now negative 4. If it is 6, it is now negative 6. And your y value is staying the same. So if you like to do it by graphing it, you can. If you like to do it just by knowing that rule, you can. Either way works. Our last transformation is going to be a dilation. A dilation is when you are stretching or shrinking a figure. I like to think of it as like when you go to the eye doctor and you get your eyes dilated, they shine a light in them and it makes your eyes like close up, your pupil that is. And it's the same thing with the dilation. So when we have a figure, I'm sticking with triangles today, but I'm going to put some in the negative this time. A dilation is when you're given a scale factor. So scale factor is telling you how much you're shrinking or stretching by. So I'm going to say my scale factor is 2. So what you have to do is figure out the coordinates for each original point. So originally we're at 3, 3, negative 0, negative 4, and negative 6, 5. So with a dilation, if my scale factor is 2, I take each of those coordinates and I multiply it by 2. So 3, 3, if I multiply by 2, 3 times 2 is 6. So that is my new point. So I put a point at 6, 6. At 0, negative 4, if I multiply both of those by my scale factor of 2, I get 0, negative 8. And that is my new point. And then lastly, negative 6, 5. I multiply both of those by 2, and I get negative 12, 10. So I actually made it a little too big, but I'll just estimate it would be about right here. No, it wouldn't, because that's negative. It would be about right here. So that would give me my new dilated figure. You also might get a dilation with a fraction. So I might say my scale factor is 1/2. You do the exact same thing, but instead of multiplying by 2, I would multiply by 1/2. So what that means is I'm finding half of each of those points. Half of 3 and 3 is 1.5. Half of 0 and negative 4 is going to be 0 and negative 2. And then half of negative 6 and 5 is going to be negative 3 and 2.5. So my dilated figure, if I was to graph those, I'd get 1.5 by 1.5, 0 and negative 2, and then negative 3 and 2.5. So whenever I have a scale factor that's a fraction, my figure is going to get smaller instead of bigger. That takes care of all of the transformations that you need to know. Hopefully you found this helpful, and if you have any questions, feel free to reach out and I will do whatever I can to clarify it for you.